All right, so I took Zach's test here. As you can see, it's a good example of 100% paper. And let's review what he did. All right, so problem number one, he is, give me 1 second here. Come on. Sorry, everybody. Trying to get my pen to work. Okay, so you can see he's just putting the square root of 3x right here, and then he's putting the 7x minus 6 over here. That's what it means to add the two equations with a little plus sign in between. Then to pay attention to the domain down there. What has to happen to make this function over here generate real answers, real numbers? Well, we have to have 0 or positive numbers underneath the square root sign. That's why he's saying it has to be x greater than or equal to 0. If we stuck a negative into here, like the square root of 3 times negative 1, that's the square root of negative 3, right? That gives you I square root of 3. This is an imaginary number. We don't want that, right? We don't want that. And so what Zach is saying is let's keep x greater than or equal to 0 to make sure that we don't have a negative underneath the square root sign. The rest of it, 7x minus 6, we don't really care about what goes in for x for that, but it's the whole function now. I mean, it has a square root of 3x as part of it, so we've got to take that into account. That's why he's saying that's his domain over there. All right, or number 2, we're plugging in x plus h wherever we see an x. Well, there's only one place we see an x in this function. So he put x plus h there. He expanded x plus h successfully. He's got his plus 5 right there. And then he's subtracting the x squared plus 5 from the f of x plus h. So he's got a negative x squared minus 5, and the x squared and the x squared go to 0, the 5 and the negative 5 go to 0. So all the terms that he has left, 2xh, h squared, they have an h involved in them. So when you divide an h into here, you just get 2x. When you divide an h into there, you just get h. So his formula for the difference quotient, which tells you the slope given some x value and how far away from that x value you are. So in this case, we are using 0.1 for the distance away from x equals 1. So it's like we've got the 0.1 comma something. I guess it's 1 comma 6. I mean, he found that out right here. He plugged the 1 in and got 6 for his y value. So it's 1 comma 6 and then 1.1 comma, well, we never figured out that y value. We don't really care, because if you use point slope form, you're going to get an equation that goes through 1 comma 6 with a slope of 2.1. Now, man, every time I do this, it seems like I pick somebody's paper and I'm like, oh, wait a minute, I now see a mistake here. Don't put the x there, because all we're looking for is the slope. Right, so 2.1 is the best answer. And you can see he put the 2.1 where it belongs. So it would be best if you wrote 2.1 times x minus 1 right there. But he's got the right idea. He's got it equal to y minus 6. And he decided to distribute the 2.1 through, which is fine. You can do that. But you don't need to. This is a fine equation right here. This is called point slope form right there. So you don't need to do anything else other than just doing that right there. All right. The last one on the paper part wanted us to graph that piecewise defined function. He nailed it. Okay. You can see that it's going through 1, 2, 3, 4, negative 4 comma 0. So that's his intercept on the x-axis. And then his intercept on the y-axis is 0, 0 right there. A lot of people put 0, 4 up here, but that's an open circle at 0, 4. So 0, 4 doesn't belong there. So you see how maybe, I don't know what he's got there, but he erased it. It looks like 0, negative 4, but whatever, he erased that. So that's good that he did that. Maybe he unintentionally flipped the x and the y around right there for his x-intercept, and then he realized, oh shoot, it's an x that's -4. Anyways, it's all x values. You can see we're going less than 0, and then we're going greater than or equal to 0, so the domain is all real numbers. And then the function to the left goes down forever, and the function on the right goes up forever, so the range is all real numbers. Oh man, I hope we're starting to make that clear, how the domain and range works. You know, if this function would have, let's say, been shifted up 5 spots, let's say this would have been x squared plus 5. Well, instead of the origin being the place that the parabola hits, it would be up here somewhere, right? At 5. Not just somewhere, but it would be exactly at 5. And the parabola would be doing that, right? Now the range would be something like less than 4, right? Y is less than 4, union, oh geez, that's a terrible union. What happened to that? Union, and then it would be y greater than or equal to 5. Boy, I wish I would have done that, you know, for the piecewise defined function, because it would have made the range a whole lot more interesting, right? If somebody was to get a range like that correct, they'd be really demonstrating they know what they're doing. I bet you guys would have got that. Anyways, thanks for watching my video. That's it on the paper part of the test.